Hi, very good morning students. Today we are going to deal one of the topic that is major topic where you can expect a question for JEE as well as NEET. That topic name is nothing but Fajans Rules. Okay, see what does this Fajans rule says is no ionic compound is 100% ionic. So you are taking NaCl crystal, it is not 100% ionic. Any ionic compound will be having some amount of covalent character in it. That is what it says. No ionic compound is 100% covalent. Some amount of covalent character is present in the ionic compound, and how much of ionic character is present in the compound will be calculating at the end of this chapter. Okay, how much amount of ionic character or how much amount of covalent character present in a compound can be calculated at the end of the chapter by using the dipole moment. But what does this say? This rule says that no ionic compound is completely ionic, means 100% ionic compound you will not find. Anyhow, some amount of covalent character will be present in that particular compound. So ionic compounds generally have more melting and boiling point compared to that of the covalent compounds. Okay, and if you go for the solubility, ionic compounds are more soluble in water compared to the covalent compounds. Already I have said polar solvents will be dissolved in the polar, non-polar solvents will be dissolved in the non-polar. Generally non-polar solvents will be having covalent bond, so that they will be more soluble in the covalent than in water. So these are only the qualitative law, means the limit does not explain how much covalent character. Already I have said how much covalent character is present or how much ionic character is present will be calculating by another thing, that is a dipole moment. But this is only whether ionic compound is present, whether covalent character is present or not, whether ionic character is present or not can be calculated by using this law. So this law is only a qualitative law. Okay, so how does it say? See, the attraction of an electron of anion by cation is called as polarizing power. See, there is an anion. Anion means generally they will be having more number of electrons. Okay, as it is having more electrons only, they will be getting anion negative charge. So the attraction of electrons of anion, this is the anion, the electrons of the anion are attracted by the cation. See, the capacity of the cation to attract the electrons of the anion, it is called as polarizing power. Okay, we are talking with respect to the cation power. See, again I am saying the attraction of an electrons of an anion. This is an ion. The electrons of the anion are getting attracted by the cation. This capacity of the cation is called as polarizing power. And electron chloride of an ion is deformed due to the attraction of cation. This is called as polarization. This is with respect to anion. See, polarizing power is the capacity to withdraw the electrons by the cation. It is called as polarizing power. And polarization means the capacity of anion to get depolarized by the attraction of cation. How much it is getting depolarized means how much the shape. See, when the electrons are attracted, see here it is round, here the shape has been deformed. The capacity with respect to cation, it is called as polarizing power. The capacity to get deformed with respect to anion, it is called as polarization. So that what happens, the original structure will be distorted. So this is called as distorted anion. Okay students, the capacity with respect to cation, it is called as polarizing power. The capacity with respect to anion, it is called as polarization. Okay, in this condition it appears like sharing of electrons like covalent character. See, generally ionic compound means it should transfer electrons, it will accept electrons. But what happens, due to presence of positive charge, it tries to attract some electrons, so that the shape in the anion will be deformed, and it appears after deformation, it appears like there is a formation of the covalent bond. So it is not 100% ionic, some amount of covalent character is present. This deformation is responsible for the appearance of covalent character in that particular compound. So presence of covalent character in the ionic compound is explained by Fajans rules. Okay, the rules are like this. More covalent characters depends upon the two factors. More is the polarizing power. Polarizing power is with respect to cation, more is the covalent character. So more is the plus charge, more will be the covalent character. More is the polarization. If high amount of deformation means the change in the shape of an anion is present, then more will be the covalent character. See, highest positive charge, more is the covalent character. Highest negative charge, then also more is the covalent character. These are the main things. Based on these things, Mr. Fajans has given rules for the covalent character. Okay, he has talked with respect to cation as well as with respect to anion. So if you talk with respect to cation, we will be talking it as like polarizing power. More is the polarizing power. Already I have said more is the polarizing power, more is the covalent character. So more is the polarizing power, more is the covalent character. Here more is the polarization, more is the covalent character. So first thing, so if you increase the more is the polarizing power means what happens? The positive charge should be increased. So if positive charge increases, what happens to the size? The size will decrease. The general thing is, if any atom is having positive charge on its own, then it will be having lesser charge. So suppose if you take Na plus Mg plus 2, Na plus Mg plus 2, Al plus 3. Which one will be having the smaller size? More is the size, more is the charge, lesser is the size. So among these three, more charge is for aluminium. So the charge of the size of the aluminium will be lesser and the covalent character will be more. So what does it say? If you are having same thing, see, as you are having different charges, you are differentiating like this. Suppose if there is like this, sodium, potassium, rubidium. Among these three, all these are plus only plus one signs. Then what happens? You will be going for sizes. This is bigger size potassium, this one is more. So if same this one is present, same charge is present, go for the sizes, which is bigger size, this one is bigger size, so it will be having more covalent character. Okay, right. For cation, more is the positive charge, lesser will be the size, and more is the covalent character. For negative one, polarization, more is the size, more is the covalent character. For cation, it is reverse. If more is the negative charge on the anion, more will be the covalent character and more will be the size. Then more will be the covalent character, right? For cation, more is the positive charge, size will be lesser and more will be the covalent character. Okay, students? See, if you compare lithium, sodium, potassium, rubidium, cesium, which one will be having the more covalent character? Which one, students? See, think these are top to bottom from a group. So that what happens? Top to bottom size increases. If size is more, charge will be less. So covalent character will be more. Okay, in this, which is smaller in size, this one is smaller in size. Bigger is the size, lesser will be the charge. Lesser will be the charge, lesser the covalent character. So, here if you see which is having the bigger size, this one is having the bigger size. So that what happens, this will be having the what? Size is bigger, covalent character will be smaller. Here it is. This one, Li plus will be having more ionic character. Cs plus will be having more covalent character. This is the thing. More is the charge. Okay. If you compare different charges, it is okay. If are of same type, okay, then what you will be doing? Lesser the size, more will be the covalent character. Right? Bigger is the size, lesser will be the covalent character. Smaller is the size, more is the covalent character. For this one, if with respect to anion, bigger is the size, more will be the covalent character. Right? If you go for the charge, if charge is more, that's what I have said, plus 1, plus 2, plus 3. If more is the charge, more is the covalent character. Okay, if you are having different charges, you will be going for the highest charge with respect to cations. That will be having more covalent character. If you are having same charge, then you will be going for the sizes. Lesser is the size, more will be the covalent character. For anions, charge increases, covalent character increases, same. Positive charge increases, covalent character increases. Negative charge increases, covalent character increases. So Na plus Mg plus Al plus 3, which will be having more covalent character. So Al plus 3 will be having more character. Okay, here F minus O minus 2 N minus 3, which is having more negative charge. This one is having more negative charge. So this one will be having the more covalent character. When you go for the pseudo noble gas configuration, okay, pseudo means any element which is having 18 electrons in the outermost shell. Then that is called a pseudo noble gas configuration. And octet configuration means which that will be having 8 electrons in the last shell. So if you take CuCl as well as NaCl, that one if you dissociate into ions, it becomes Cu plus as well as Na plus. Cl minus is the common thing. In Cu plus, the valency configuration will be like 3s2, 3p6, 3d10, means 2 plus 6, 8, 8 plus 10, 18. So in the valency shell, 18 electrons are present. So 18 electrons means pseudo noble gas configuration. Okay. Here in Na plus, you will be having 2 and 8, so 10 electrons in the valency shell. So this one will become, so 8 electrons in the valency shell, it becomes octet configuration. So whenever there is a competition between octet as well as pseudo-octet configuration will be having more covalent character when compared to the octet configuration. See students, again I am repeating, this is one of the major content where you can expect the questions. So if you are having same positive charge on the things, lesser is the size, more will be the covalent character. If you are having different charges, means plus charge only, more is the charge, more is the covalent character. With pseudo configuration as well as octet configuration, pseudo configuration will be having more covalent character. With respect to anions, more is the size of the anion, more is the covalent character, more will be the size. With respect to charge and anions, more is the charge, more is the covalent character, more is the charge. Right? These are the examples. These are the things. This is the 4 marks important question, as well as you can expect questions in JEE as well as NEET. Right? Applications. By knowing the applications, we can find the many properties. Like if covalent character is more, ionic character will be less. This is a common thing. Right. Based on the covalent character, some properties can be identified. If covalent character is more, if you are having more covalent character, then solubility will be decreased in water. See, generally water is a polar one. If covalent character is more, then it will be organic compound. Then automatically solubility will be less, because this covalent compound, whenever it is more, it is a non-polar compound, but water is a polar. So non-polar with polar. Okay, automatically decreases. Then melting point, what happens? If covalent character is more, melting point decreases. If covalent character is more, color imparting nature increases. More is the covalent character, more will be the color distributed to the solvent. More is the covalent character. Generally, the covalent compounds exist as gases, liquids, soft solids. Generally, covalent compounds will not be as solids. It is a rare condition. It will be generally as soft solids. Major conditions, they will be existing as gases as well as liquids. So, students, based on the above conditions, we can solve these questions. Covalent character is present more in, see, NaCl, KCl, RbCl, LiCl. What is common is Cl. You can remove the Cl. Okay. Next, go for the charges. Na plus, K plus, Rb plus, Li plus. Means all are cations. If cations are having same charge, are they different or same? Na plus only one charge, K plus is only one charge, Rb plus is one charge, as well as Li plus is one charge. So now go for the sizes. As the charge is same, you are going for its size. First you should go for charge only. Okay. Here you are going for sizes. Which one is smaller? That will be having the more. So Li is having the smallest size when compared to sodium, potassium, rubidium. So this one will be having the more covalent character. Okay, LiCl is having more covalent character. D is the answer. Suppose go for this example: BeCl2, MgCl2, CaCl2, SrCl2. Cl2 is common. So Be plus 2, Mg plus 2, Ca plus 2, Sr plus 2. What happens? Which one is having more covalent character? Go for the sizes. Which is having the lesser size? So obviously answer will be this one. Beryllium is having the lesser size. So BeCl2 will be the answer. Next, which one will be having the high melting point? So among these compounds, first identify which is having the highest covalent character. Already I have said, whenever the covalent character is more, the melting point will be lesser. So question is high melting point. So first you identify the lesser one, go for the reverse. If covalent character is more, melting point will be less. Means if ionic character is more, melting point will be higher. Okay. So you identify beryllium, magnesium, calcium, this one. All are fluorines, so you can remove fluorines. So which is smaller size? If you go for beryllium, magnesium, calcium, strontium, top to bottom, these are beryllium, magnesium, calcium, strontium are top to bottom in second group. Strontium is bigger in size. Bigger in size means it will be having more ionic character. So more ionic character means more melting point. So answer will be D. In the same way, students, you calculate for this NaCl, CuCl, KCl, AgCl, and which is more soluble among this, and which of the following is the darkest in color. And we know in this we have learned generally covalent compounds exist as gases, and above point is they will be having more color imparting nature. So darkest means which is having more in among this, which is the more covalent one, you find out, that will be the answer. In the same way, PbCl2 as well as PbI2 also you identify the darkest one. Among the following, which is more volatile? Volatile means any substance which directly converts into gas state. When you keep in the air, it directly gets evaporated. Simply we can say liquid. Suppose if you take petrol and you keep it in air, what happens? It gets volatile, means it gets into vapor states. So any substance when exposed to atmosphere, if it gets evaporated, then that substance is called as volatile substance. Okay. See, volatile means generally they will be in the form of gases only. Okay. So among these two, which is having more charge or which is having more covalent character? This one is Sm plus 4, this one is Sm plus 2. Sm plus 4 is more, so it will be having more covalent character. So Sm plus 4 will be the answer. So students, solve this paper, and these are the things for this session. And in the next lecture, we will be continuing with the covalent bond. Thank you, students. Have a good day.